30. Wow. So this is IPSECME, IETF 121, and we seem to be first session in the whole meeting. So normal problem seems to be happening with the data tracker at least. All right, so I'm Tero Kivinen, and my co-chair Joab is not online. Might be trying to log in, or might be still. No, actually, it's 2 hours later. I think so. It should be later. Here's the note well. And so we have already one note taker, and if other people can join and help there, if you can get to the note page and the MeetEcho page. MeetEcho, even if you can't find the, for example, the agenda still doesn't work for me, but that link takes you directly to the MeetEcho, or you can scan the QR code. That probably takes you also there. So we have a quite full agenda. We removed some of the items from there because we didn't get any slides, but so we have 10 minutes open, any other business in the end. So is the agenda. Does anybody have anything that they want to comment on this? We did in the note well, we did the technical difficulties. Now we have to do the agenda bashing. I don't see anybody commenting.
Yeah, Tero, there was data tracker was there was an outage, so you couldn't get to the agenda. They just fixed it a minute ago, so probably going to get a bunch of people joining right now.
Yeah, there is people arriving here. Actually, the login was working, but the agenda wasn't really. That was the same for me.
Right.
Okay, so that's my co-chair. You're out there. Managed to join a little bit late.
I'll turn off my camera and become the disembodied voice.
Yeah, right. All right, so we have several presentations, and then so it starts with the document status. So we have not published any RFCs since last meeting, but we have one GI version 2 is now. I have actually done the review. It was a little bit more than just to look it through because I had to, go through it a little bit more. And Outsource has already updated it, and I have a separate write-up that I need to just upload and make sure everything is right, and then we'll push the button to make it, start processing this. And it would be good thing to have even more reviews for that, but I guess but we want to get this one out because this is the old stuff that is from the MSEC and or came to us from other working group, and we have been just mostly making sure that it actually is like version 2, not like version 1. Then we have this QR out. It's still in the working group last call. There's only comments on the working group last call has been me and the authors, and that's not actually a very good sign. So I would like to actually get a couple of people at least, say in the list that they have read it and that they it's okay to go forward, because I mean, if it's only me and authors, that doesn't really show that there's too much interest on it. And also there is this question about what is the, because it's using a different way of generating the crypto stuff that is done in it's following what is done in this QR draft. It's not doing the same thing that was done in this multiple additional exchanges draft, or RFC. So I was thinking about both of those RFCs, so we can actually follow either one of them. But I was thinking the other one was newer than what is currently used, and I was thinking, was there any reason why we actually changed there to do that way? And that's why I want to get people to actually look at and think about if there is any differences between the two different ways of doing the key generation. And then we have two documents: Diet ESP extension, which already expired, and the Diet ESP, this has been on the list to be almost ready for a long time, and I haven't seen any comments on them for a long time. They are actually in our charter, so that they're actually listed there, I think, correctly, both of them. So we should be pushing those out just to clear out the table. So I will probably start the working group last call. Does anybody have any comments on those? Are they ready? Anything about those? I don't see. Oh, Daniel. Go ahead, Daniel. Daniel? Oh, yeah.
Can you hear me now?
Yes, we can hear you now.
Yeah. Okay. So I just published a new version yesterday for the IK extension. I think the documents are almost ready. The only thing we're trying to do by this week or next week is to add an example of our implementation with OpenShift for the ITSP. But otherwise, we think it's ready for working group last call.
All right. So you are going to make a new version of the draft.
The ITSP.
ITSP. Okay. And then there should be ready. Okay. I will wait for that, and then I will start the working group last call for them.
Okay.
And hopefully people will actually read them at that time and send the mail to the list and say that they have read it and whether they think they're a good idea or whatever. Right?
Okay, perfect.
Okay. And then we have the one TS payloads opt draft that is still in working process, and I haven't seen any discussion on that for some time either. We seem to be having very sleepy working group for at least for the items we actually have in the charter and in draft working group drafts. All right, so I think that does anybody have any other comments on the actual work items that we have currently in the working group? If not, I think we can then start to there seems to be lots of interest in adding new stuff because we have lots of presentations. So let's start with the first one. So auto replay notification. And if you could just say next slide and I will advance.
Hello, everyone. My name is Weipan. Today I'm going to present this draft about the anti-replay status thing and the ESN. Next slide, please. First, I like to highlight about our problems in the high traffic volume scenarios, because in these scenarios, the operators often choose to disable the anti-replay function, especially on the high-speed connections for some reasons like queues, performance. The reason is to avoid the disordered packets being dropped due to the it exceeds the window size of anti-replay. And but high traffic volume also means that the rapid consumption of the sequence numbers. So 32-bit sequence numbers may be exhausted in minutes, and therefore the child essays would be rekey frequently. And 64-bit ESN is better to be chosen in this scenario. But for many IPSEC implementations, ESN requires anti-replay. And although RFC 4302 and 4303 does not prohibit using ESN when the anti-replay function is not enabled, but so many IPSEC implementations do such thing, and this is also can be considered as comply with the RFCs. So you can see that in the RFC it says the receiver should not negotiate ESN when it not enable the anti-replay, but it's not a must not. So either way, comply with the RFC. So nobody did wrong, but the outcome was not what we wanted, because ESN can't be negotiated, and the 32-bit SN exhausts rapidly, and therefore their child SA is also rekey frequently. Next slide, please. So the problem is, can ESN be used without anti-replay? First, let's look at why ESN is bound to anti-replay, because the high order 32 bits of the ESN is not transmitted on the wire, and the anti-replay window is can be used as a mean to tracking the high order bits of the ESN. And RFC gives an example of the mechanism of using anti-replay window for ESN. So we think ESN can be used without a replay because the RFC first don't prohibit doing this. And if you need to determine the high 32 bits, you need a separate window. And because there is no anti-replay window. And this can be a local policy because any implementation can choose to do so and can choose not to do so. Valerie?
I don't think that this interpretation is absolutely correct because actually you don't need an anti-replay window to guess the upper 22 bits of the ESN. So in the algorithm from the RFC 3303 and 3302, you may set the window size to 0. So that means that you don't have anti-replay window. And these algorithms will still work if you implemented them correctly. So you still need to maintain some state, an expected, the current expected up at 32 bits of the ESN. And you have to do some processing, but actually you don't need the window itself. So it is not absolutely bound to anti-replay. You still need some code to maintain, to guess the upper 32 bits, but you don't need to have any anti-replay window to do this. At least as far as I remember when I read those RFC, and I today just rechecked, and I think that I believe I'm correct. So you may.
Okay, thank you. And the one thing I need to clarify that if you enable anti-replay, or even if you set the window to 0, but when you guess the high bit, the sequence number wrong, the packet will be dropped due to the anti-replay, not due to the ESN decrypto process. So so this is one thing. Next slide, please. And so if one can support using ESN without anti-replay, then its ESN capability can be abstracted in this table below, and you can see 4 cases, and 3 of them the peer has the ESN capability, and the only case is that of disabling replay protection and does not supporting using ESN with anti-replay will cause the peer has no ability to use the ESN. Next slide, please. So when you combine 2 peers, there are 16 cases of the ESN negotiation. 9 of them will have the ESN successfully negotiated, and 7 will fail. Next slide, please. Among the 9 successful cases, you can see there are 3 sub-categories. First, if both peer enables anti-replay and the ESN can be negotiated successfully. And second, if both peers support using ESN without anti-replay, the ESN can be negotiated without, regardless of the status of anti-replay. And finally, if one peer disables anti-replay and supports using ESN without anti-replay, but the other peer did the opposite thing, but the ESN can be negotiated still. Next slide, please. So for the cases, if either peer disables anti-replay and doesn't support using ESN without anti-replay, then the ESN won't be negotiated successfully. Next slide, please. So in summary, the above part summarize the statements in the 2 pages above, and so you can see whether supporting using ESN without interplay is actually a local policy, and any implementation can choose to do it or not. Therefore, for us, we have a question is that it seems like the IPSEC implementation don't have to notify the peer of this capability, and do we need to notify the peer, or do we have some other process needed? That's a question we need to explore. Next slide, please. So for the cases that ESN cannot be negotiated to use, we consider what we can do to improve the outcome. First, when you look at the cases when both peers disable interplay, in this case, ESN isn't successfully negotiated, and each peer actually does not need to check the sequence number of inbound packets. This is described in RFC, and also each peer does not need to monitor or reset the sequence number counter of the outbound packets. And yeah, it's also described in the RFC. So actually, when both peers disable interplay, then the child essay don't need to be rekeyed, because even if the 32-bit SNs are exhausted, the sender just need to roll over the counter and does not need to trigger the rekeying. Next slide, please. And for the last 4 cases, notifying the anti-replay status to the peer would also benefit if the receiver, if the high volume traffic only happens in the direction that the receiver disables interplay. And in this case, the sender does not need to monitor the counter, and the receiver doesn't check the sequence number. So even if if this direction has the high volume traffic, then the essays will not be triggered to rekey. Next slide, please. So in conclusion, for the cases that ESN can be negotiated to use, notifying the status of replay protection to the peer can help improve the outcome, because the sender does not need to unnecessarily monitor the sequence number and trigger the SA rekey. Next slide, please. This is currently the notification we design in our draft, but maybe we can explore some other means or better solutions. We can just go quickly about this. We have this notification in the IKOS exchange and the create child SA exchange to tell the to notify the peer of the status of replay protection and the status of supporting using ESN without replay protection. Next slide, please. So finally, we have some more things to consider. First, whether we should notify the whether this using ESN without interpretation should be notified to the other, and how it is notified by the notification payload or during the ESN transformer adding a new option. And second thing is that if the IPSEC implementations can maintain a separate window for ESN, should the window size be negotiable? Because actually the window size of interplay is not negotiable. So maybe we don't also need to do that. And yeah, thank you. Any comments?
Yeah, sure. When I set the bit in the new notification that says that I have replay protection, this means that I'm checking the numbers, right? I mean, the standards up until now were always that you had to set the numbers correctly, whether ESN or not ESN, and then I have the option of checking or not checking. I'm not sure what the benefit is of me stating that I am checking the number, the replay protection, rather than not checking it.
Can you repeat that? Because
Okay. So again, we always had the RFC saying that the sender has to send the sequence number in sequence, and the verifier could either verify it or not verify it.
Yeah.
So why do we now want? What's the benefit of having the verifier state that yes, I am verifying things, the sequence numbers?
Currently, when because the receiver, the sender always need to assume the receiver enables this check, this verifying. So the sender needs to monitor the sequence number, and if it exceeds the end, it needs to trigger a rekey. And yeah, for if you only use the 32 bits sequence number in the high volume traffic scenario, the rekeying would happen frequently because the sequence number is exhausted frequently. Yeah.
So the point is to avoid doing the rekey.
Yeah.
Okay.
I think that one point. Well, first of all, I think that the draft ties different things that should be treated separately. And I think Scott made a very good comment on the list that there are a few things, that there are several things that are different. First thing is how you recover an up 22 bits of ESN on the receiver. And the other thing, whether it is concerned with replay protection, the other thing, whether it is allowed to wrap around the sequence number on the sender, and so on. And I think that they should be very carefully treated separately. Because, for example, if you allow a wrap and sequence number around, then it will immediately cause problems for implicit IV encryption transforms from RFC 7850. And I can't see any mention of any discussion about this in the draft. And especially if you do this via notifiers and negotiate transforms. For example, initiator can offer both explicit IV transforms and implicit IV transforms in the same SA payload. And then the status of interplay protection will apply for both. And you can't do it if you allow a sequence number to wrap around, because if the responder selects an implicit IV, it means that all security will be void for them. So I think that there should be more discussion about all these things, and they should be very carefully sorted out. And the current draft just mix all of them into the one big problem. And that should be treated separately, I think.
Okay. One reply is that actually in the draft 00, the last version, actually we just proposed to sending the status of replay protection to the peer, and we didn't consider of using ESN without entry replay. And previously, I thought that was a easy solution, and by notifying the peer, I will not enable entry replay, and you don't need to monitor the sequence number. But recently, some discussion told me that the crypto processing may need to use these 64-bit sequence numbers. So so just notifying the status may not be enough, and may not be functional in some cases. Maybe, yeah.
I I think the draft needs security considerations for turning off anti-replay. I think that is actually a bigger like IC responsibility, but I think we cannot publish new drafts and relying on the security thinking like 20 years ago. I posted recently, Ericsson recently wrote some considerations for anti-replay to NIST. I posted this in the draft. 3GPP mandates replay for everything, so I would not have any use for this draft, but I think it would be good if we have some notification that a node is planning to not use replay protection. I would like to see. I think it's wrong in the design of IKE that this is a implementation consideration. I think it should be visible. A node should be able to not communicate with someone that wants to turn off replay protection. But there's also maybe a more general discussion than this draft specifically.
Okay. Do you mean the previous security assumption or security consideration is that we need always to use anti-replay, or
In general, I think you need to use anti-replay unless you have very like if you have done very thorough analysis that you don't need it. There is like TLS 102 spends 2 pages talking about when you can use zero RTT. I think that's a good way to look at this. Like if you turn off anti-replay and you have anything on the top that are not doing replay themselves, you typically get into a lot of nasty problems. That said, if you have like HTTPS only on top of IPsec, then maybe you don't need anti-replay protection, but I think that's a special case.
Okay, actually, but our problem is from the real case, because in our many of our customers, the telecom operators, choose to disable anti-replay, and they found that the ESN won't be negotiated, and the rooking happened frequently, and that's the real case for us. Yeah.
Yeah, according to 3GPP standards, you're absolutely not allowed to turn off replay protection for very good security reasons. Then you end up in big security problems because nothing is designed for that. I would maybe rather see efforts to how can we do replay protection more efficient than how do we turn it off. But yeah, it would be good if it's visible.
Okay, I'm good to hear what you said, that 3GPP suggests not to disable.
Not suggest, it's a mandate. You must use replay protection always in all IPsec. Yeah.
Okay, I'm happy to find out this requirement, and we will do more research. Yeah, thank you. Maybe I can reach to you later. Yeah.
Paul?
Paul Wouters, an individual. So just in response to this, usually the application has to handle this anyway, right? Because either it's TCP and it has sequence numbers, and so the application layer is already dealing with replay, or your application itself is UDP based, and then it already has to do replay protection too, independent of like where the IPsec layer would do it. So one of the reasons that most people, when they hit performance issues where you get lots of packet drops, because you specified the largest replay window that your operating system allows, and you're still going to have to drop packets because of like out of order delivery. People are saying like, let's move this to only the application, not have both the application and the IPsec layer do it, right? So that was one of the arguments for doing this. So I just wanted to bring up that one of my problems still with the draft is that we now have most implementations that do not support doing the ESN and replay protection options separately. As in, if you want to use ESN, you must have replay window protection. And of course, the ironic thing is that most people that have high-speed links that's seeing issues, they're going to say, like, let's disable replay protection. And when they disable it, they accidentally disable ESN, and now they're rekeying every minute because, like, they accidentally disabled ESN. And so what the draft is trying to do is to say, like, okay, let's find a way where we can, like, not have these two things tied together. But since the implementations have them tied together, we need a way of relaying this to the other peers, saying, like, this is an implementation that actually supports this. So there's kind of a need for a notify that says, like, I can do ESN when I disable replay protection. Now, the problem is, if you send that notify in IPSECME init, then for the initiator, that's fine because it knows what configuration it's using, but the receiver doesn't know yet which peer it's talking to. So it might have a configuration where it allows this for one peer, not the other. So you can send the supported notify in the IPSECME init, but it doesn't mean that your connection will be configured later on. And then when the initiator sends the packets in IC author and create child assay, and it says, like, okay, I want to do no ESN here, or like I can do this now because of the peer's replay protection capabilities, then it's kind of too late because the initiator has already sent its must already commit to its ESN traffic selectors before it actually knows from the peer whether it's going to allow replay protection to be disabled and ESN still being used. And so I think in ICAuth, it's kind of too late. And in IPSECME init, it's too early. So I don't have a good solution to do this other than saying, like, in these cases, the initiator just has to terminate the connection and then try again.
Anthony?
Hi, Anthony. I would like to bring a bit more focus onto the ESP parts, but not the notification and what you should do. Because if you do really read the appendix A03 and parts, like, I think it's really sophisticated implementation. You need to. So does this people who are turning off really implemented the whole thing, or are they partial implementation? The most of the things Paul is talking about is due to the problems in Linux. It's a partial implementation. And I believe that the appendix even says if you guess it wrong, you can take a next higher order 32-bit and then re-inject it, which I'm not sure any hardware would ever implement it. So I would invite to specify, when you're specifying the whole problem, how much of that three or four part RFC which is actually implemented. Because a lot of people are assuming, like I think Valerie and others are assuming everything is implemented. And there's one last part in that is, like, if you lose, say, 2 to the power 32 packet, then the IPsec stack should notify the user daemon saying, like, oh, you dropped it. Now you fix the whole thing, which I haven't never seen it implemented. But if you implemented everything, then things may work. So before blaming the RFC and getting into solution to say, like, what is the problem?
So you are saying we should actually implement the RFCs, and only after we have done that,
now, if
then we should be, complaining about adding new features.
That is one way of looking at it. But if not, you should say, like, in the draft, I hit this problem because I didn't implement this, which might also help. Like, because if it's Linux, I would just say, like, we haven't implemented this and we didn't implement the reinjection. We only have one guess. And if you get the guess in the wrong, we drop the packet. And we also don't notify the IC daemon saying, like, you drop the packet, do something about it.
All right. So I think we're running out of time.
Yeah. I one last sentence, and we will go back to do more hack or test of this, whether how to use using ESN without any replay protection, and we also would like to hear from the ESP implementationers about whether this can be doable and what problems can be encountered, and that's all. Thank you.
All right. So that was first presentation. Next one, Stefan.
Okay. Hi.
Yeah.
Okay. Yeah, I'm presenting about the enhanced ESP draft that we published recently. So next slide. So first, some words why we think a new security protocol is necessary. So ESP is kind of inflexible, and the biggest problem here is that ESP doesn't have the version number in the packet, which means that you have to negotiate all the new features that you want to have, which is in turn intransparent to the outer network. And we already had quite a lot of proposals to extend ESP here and there, but all those proposals suffer kind of from that limitation that there's no version number in the packet. Another thing is that we kind of should be little bit more hardware offload friendly because ESP is pushed down to hardware quite often these days. And so Google invented the PSP protocol. They use that for their data center traffic. It is pretty similar to ESP, but kind of more flexible. But unfortunately, that's not a standard. And that's why we think it's time to get something new here. Okay, next slide. Okay, some takeaways from my last presentation about wrapped ESP version 2 at the last IETF. So essentially the feedback was, they said, well, go big, define a new ESP, go for a new protocol number. Don't hijack any existing protocol just because you don't want to ask for a new number. And that's what we're doing here now. So the other thing is, if you do ESP new, you can simply fix all the existing problems with one document, so you don't need band-aids for ESP anymore. And this is by far the most flexible and future-proof solution that you can have here. Another thing is that in wrapped ESP, there is a crypto offset hard-coded where you can show some bits in front of the packet that is not encrypted, and a couple of people didn't really like it. Yeah, so with the new proposal, we cut that out there and put it in an optional part. So we hope that everybody is happy with that now. Okay, next slide. So let's talk about the packet format. Next. So this is the top level packet format of an ESP packet where we divided the header in 3 parts. First part is the base header. This is interesting information for middle boxes and the IPsec peers. Second part is the peer header, which carries information that should be kind of private to the IPsec peers. And then we have a payload info header. This carry information that ESP has had in a trailer. So we cut out a trailer and put those information in front. That's what the payload info header is for. Okay, next. So this is the base header as we define it. So we start with a 7-bit version. Then we have a flag for a packet format. I come later to that, what it is. Then we have option length field, which defines the overall length of all possible options that might follow that header. Then we have a new session ID and the SPI as usual. And this is followed by some TLV encoded options. Okay, next slide. Okay, next thing we have is the peer header. This has just 2 well-known fields, the sequence number and the IV. And in contrast to ESP, we transmit always the full 64-bit sequence number if we do replay protection. If we choose to don't do replay protection, we do not transmit it at all, so we cut it out from the packet. And the IV is as usual, it depends on the crypto algorithm. It's just like we use it in ESP. Next. Okay, and this is the payload info header that is used for the full packet format. We have actually 2 packet formats. One is the full and one is the optimized one. This is the full one, and this is required for transport mode and IPTFS because the next header field can't kind of derive from the outer IP because this is set to ESP, so no way to get that. And the same is with the path length. It can just not compute it from the outer header. So you have to kind of have that explicitly in the header. And that's what we have there. It's essentially that what we had in the trailer on ESP. We just place it in front. Next slide. The other thing is the optimized packet format, which does not need this payload information header. And essentially that's a tunnel mode because you can derive everything what you need. So the first nibble in the IP header defines the version. So you actually know if it's IPv4 or IPv6. And with that, you can compute the path length, right? And next header is simply not need in tunnel mode because it's either 4 or 6, and that you know. Next slide. Okay, here is a comparison of the 2 formats. On the left-hand side, you see the full packet format, where you see in red, the packet format flag is set to 0, which means that we have the payload information header in the packet, which you can see in red here. This header is followed by the layer 4 payload data in transport mode or in IPTFS. On the left-hand side, you see the optimized one. The packet format flag is set to 1 here, which means we do not have the payload information header. So the IV is directly followed by the IPv4 or IPv6 datagram. So that's basically the difference between these 2 formats. And with the optimized formats, you just save 4 bytes for each packet, but we think it's kind of worth doing it. Next. Okay, let's talk about options. Next one. So options here are TLV encoded, and we basically adapted this from IPv6. So whenever you can parse IPv6 extension header options, you can parse that ones too, because they're exactly the same. So with that, as for IPv6, you can just add multiple options that can follow every header, and future documents, if they need some new options, can just define new ones. That's pretty open to everyone. Another thing we have is just we have a kind of reserved space for private options. So whatever is not kind of standardization can go there. So there's even space for private stuff. Next slide. So option types. So in the draft, we define 3 option types, which is one is the flow identifiers, which is the most interesting one for us, I think. Then we have the crypto offset, which comes from Google PSP, basically. And we have padding options to get alignment right. But as said, future documents can define new options on their needs if required. So next. Well, that's a simple flow identifier here. Is a TLV thing. So we have type length in front, and it's followed by a flow identifier that should just carry a characteristic information of the inner flow. So in that document, we just define this simple flow identifier, but if anybody needs something more fancy, just define a new one. And use cases for that simple thing could be for intermediate devices to do eCMP or RSS or whatever. Next. Yes, that's the crypto offset option. As I said, this comes from Google PSP. They require that. So this has basically a payload offset field, which points to the start of the inner packet, that you know where the inner packet simply starts. And it has a crypto offset that tells you basically how deep you can parse into the packet until the encrypted part starts. And again, for PSP use case, we have 2 flags reserved, but I don't want to talk about that here. We can talk about that offline. Okay, next slide. So, and that's how it's looking like. At the top of the slide is a packet shown without crypto offset. Everything is as usual. The whole inner packet is encrypted. And at the bottom of the slide, you see a packet which has a crypto offset option between the base header and the peer header. And here, if the crypto offset is positive, you can show some parts of the inner packet as it's done here. So here we show the payload information header and the TCP header, and encryption starts just at a payload. So that's the use case for this crypto offset option. Next. Okay, padding, as I said, we just took pad 1 and pad n from IPv6 to align the following headers. That's all what we do with that, but it's required depending on the options if you need padding or not. Future use cases could be use that also for ciphertext alignment, but that's out of scope of that document. We just use it to align the inner headers. Next slide. Okay, and that's basically it. So let's summarize the major changes, what we did to ESP. So the most important thing, I think, is that we add a version number, which means that we do not need to ask for any new protocol number anymore for this ESP protocol. So we have now an 8-byte base header, which includes the session ID, and this is followed by variable header options, whatever you think here. And we have the sequence number. We transmit the full 64 bits if we do replay protection, or we cut it completely out if we don't do it. As said, we have 2 packet formats, the full one and the optimized one. And to be mentioned, we removed all the implicit header parts here. We also removed the trailer. We put that in front. This is the payload information header now. And also we do not do TFC padding anymore. We recommend to use IPTFS instead. Okay, next. So that's basically it. So because that's kind of new, we have some questions about it, of course. So we use 2 packet formats. We have the optimized packet format, which saves us 4 bytes on each packet, which we think is quite a big thing. But it also adds some complexity to the protocol. So other people may think different about that. So we want to hear some feedback from the working group if that makes sense or not. Same is true for the TLV. We find this is quite flexible, but other people might think different about TLVs. So input from the working group would be very welcome here. Another thing is the question of the process, because ESP looks in large parts pretty similar to ESP, and the question is how to handle that. I mean, there are two options. We could either reference all the identical parts to ESP in the ESP draft, or we can copy out from ESP and put the text into ESP. Both has advantages and disadvantages, but we kind of, unsure how we do that. So any input from the working group would be nice here too. And that's basically what I had to say. So I'm open to questions now.
So I forgot to update the slide with the 4-byte thing, but just to give a sort of example, if you had a 10 gigabit link, I think it's like up to like 10 megabyte a second that 4 bytes represents, just to give some kind of relative. So it's kind of decent size.
First of all, thank you for this effort, and I read the draft. It's very interesting, and I think it's very important, and it brings new features that ESP is definitely missing. And there are some questions that I think they should be discussed. And I already asked a question why SPI is in the base header and not in the peer header. And perhaps the same question for session ID, because from the draft it seems that it is used for example, CPU pinning. That is, in my understanding, it is also should be in the peer header because CPU. I mean, I understand that CPU is on the receiver part, and the question is how it is negotiated or generated. So all these things should be clarified. They're just not clear for me from the current draft. But I think that overall the draft is a good starting point for discussion all these shortcomings of ESP. And I think this is the work and discussion should be continued with the draft with a possible adoption.
Okay, thank you. Yeah, I have to say we did not really think about how to negotiate all that. We had just 3 months and we were just caring for the packet format. And if the group is okay with the packet format, the next thing what we will do is to care about how to negotiate that.
Palvat's individual. I just wanted to say as well, thank you very much for doing this work. I know it was a really slow start in getting people convinced that we needed to do something to bring IPSEC into the current decade. So thank you for doing that. Yeah, really excited on seeing this work move forward. I'm a little amused that you're talking about the optimized packet format and being proud of 4 bytes that you can save when you just wasted them on transmitting the full ESN, right? So it's like the de-optimized, re-optimized packet format.
Well, yeah, but
yeah, I agree.
Yeah, but the implicit part of the ESN, this was, I think that was really a bad design decision that was taken back in the days.
Scott Fleur, Cisco Systems. I'm just going to make one comment about a question you asked about whether or not you should refer to 4301 or just copy as necessary. I would strongly recommend you copy it. If you remember 2407, 2408, 2409, how they referred to each other, it was a mess. Everyone hated it. Let's not go back there.
Yeah, okay, thanks. I mean, we happily take that advice.
Yeah, and we've already had a few meetings on this, and that tends to be the general gist that everyone keeps recommending. We just sort of miss it.
Yeah, right. A couple of people recommend that already, but we just wanted to have it in the working group to find a consensus on that.
Hello, it's Liang Xia from Huawei. Thank you for bringing this. I think this is a very good document and important, interesting question thing. But I have a dumb question. I'm not the IPSEC expert, but can we have we because this draft is a lot of technical details, but do we have any materials or any background materials to clarify what is the use case or what is the requirement that we need to this new generation of ESP protocol or definition?
Yeah.
I know this draft this document material are all technical things, but I want to see the requirement, use cases, and the gap.
We have some use case in the draft, and we also referring to a problem statement draft what was published a year ago, which it describes in details what the problems with ESP are these days. So you can just read.
Okay. Thank you for letting me know. Yeah. And I have a comment about the draft. My first feeling that you have included a lot of extension or the improvement of the ESP current ESP protocols. So will you consider separate them into different drafts? Because maybe one draft is too, so many things. It's very hard to solve everything in a time manner.
Yeah, right. Well, I think that draft can kind of seen as a kind of an infrastructural draft that gives you the possibilities to add stuff, and we just add the basic stuff what we think is immediately necessary. But if you think you need something else, we just give you the tools at hand that you can do that yourself in a follow-up draft.
Okay, thank you.
Hello, Wei Pan from Huawei, and actually, I have some talking with you previously, and about the motivation or problem statements of this draft, and I think several of my drafts are also the motivation, and I think first I support this work, and I think the current work can address my previous concerns of the ESP, for example, about the trailer part for being hard to be processed by the hardware, and about the flow ID options can be used by our multi-VPN draft, and I support this work.
Yeah, okay, thank you. I mean, that was the plan, that we kind of can cover all these things, and if we don't do, just let us know what's missing so we can still adapt that.
Balvo, sorry again. So I did forget to respond to the latter part about the process. So as an ISG member, I know that we've talked a lot about what is the best thing to do about a BIS document. Where do you want to do it? An old new div inside the RFC, or where do you want to refer them to other ones? And I think generally speaking, the ISG at least would like to see only this like sort of new and old side, like, replace paragraph 5.3 section 4 with this is the old text, that is the new text, something. They don't really like that, because also from an implementer's point of view, you now need to read an old document and a new document, and then you accidentally start reading too much of the old documents. Now you implemented the wrong thing. So where possible, define new things, but if it's like large copy and paste works that have unmodified text, then you can refer to an old document if you want to. But yeah, I would also err on the side of making a document standalone, and that you don't have to have like two documents open to implement things.
Right. I mean, that would be my preference to just have one single standalone document here, and I guess most people are on that page, right?
Daniel?
Far, Anthony, so far in the packet format, this seems to be okay. Once we go into IPv2 and UDP and other things which the document should cover, and copy paste, I think would be really make the document big. That's one reason authors bring up this question to say, like, because ESP also, like, there are quite a few details, like the whole ESN things and how much of it we should copy it.
Okay. Daniel, go ahead.
So yeah, I like better definitely to have a single standalone document as well. But my question was actually, do we know how much overhead this new ESP introduce regarding a standard ESP?
Well, if you don't use any options, then I think you have 4 bytes more in the header.
Okay, but I mean, I think we will use that with options. Do we?
Yeah. Okay, maybe there are 8. So
8.
Yeah,
okay, yes. So that's
yeah. I've just, I mean, but this is because we transmit the complete sequence number, what was recommended also for ESP, and we just use it here. And then we have this base header in front. We just kind of need this version, so that gives us another 4 bytes there. So yeah.
And Daniel, you mentioned that you thought that options would be used a lot. We don't think so. I don't
Okay.
think that.
Yeah, but
I don't think most people are going to do crypto offset or flow.
Yeah, I think flow identifiers are
more common.
I think they will be more common at once.
Right. So I think we need to.
Yeah, but that's a great work. Thank you.
Think these things to the list and continue there. And this is actually one of the things that is. I don't think this is in our charter currently, so we need to recharter, and that's actually one of the things I have an item for a future anyway, that we actually need to do rechartering anyway, and this is one of the items that I think we want to do. But I mean, this is not a minor extension anymore.
No, not at all. Yeah.
All right, so let's go to the next presentation anyway.
Then let's recharter
and continue
okay,
this on the list. All right. Or about 10 minutes late, so we used to 10 minutes in the end anyway.
Before you drive the slides. Yeah, cool, thanks. Okay, hi everyone. So this is a new draft as of this IETF, which is looking to put SHA-3 inside IKE and IPSEC. Next slide, please. So more specifically, we're looking to specify SHA-3 and KMAC to be used in the PRFs within IKE, to be used as integrity algorithms used to protect IKE and IPSEC security associations, and as the hash function to be used in the digital signature authentication method. Next slide. So a bit of motivation. Why do we want to use SHA-3? Currently, in a lot of places, SHA-2 is used, specifically in PRFs, it's used quite prevalently. This is insurance against any potential future weakness in SHA-2. I don't think SHA-2 is going to break anytime soon, but if it does, that's sort of why SHA-3 exists. So in my mind, it makes sense to specify it. A more compelling reason in my mind is if you're creating an implementation of IPSEC that needs to be post-quantum, and you're using the NIST post-quantum algorithm, so that's MLChem, MLDSA, SLHDSA, they all use SHA-3 internally. And so if you want to create a cryptographic library that is goes through some kind of assurance or accreditation or evaluation, you may want the smallest cryptographic library possible. And if you already have to implement SHA-3 in your post-quantum algorithms, you may want to just use SHA-3 everywhere and get rid of SHA-2. So it lets you have a smaller cryptographic surface area for kind of high assurance post-quantum IPSEC implementations. And finally, if you're using KMAC, then that's an extendable output function. This is just a more modern way of doing key expansion. It's more efficient to use this. I sort of suspect if we were creating IKE v3, we might be looking at using XOFs to do our key expansion. Next slide. So here's specifically what we're looking to standardize. So we've got HMAC SHA-3, 3 slices of that. This does the obvious thing. So this is basically taking HMAC SHA-2 and then putting SHA-3 instead of SHA-2. We're also looking to specify 2 KMACs for the PRF. We like this because it means when you call PRF plus, this now becomes a single call to the KMAC extendable output function rather than iterating SHA-3. This makes it more efficient. There's a slight change required to the PRF plus implementation because you now have to pass the length that you want into the underlying PRF when you call PRF plus. It's a very small change, but it is a change nonetheless. Next slide, please. For the integrity transforms, for the auths, again, we're doing something very similar with HMAC. So take out SHA-2, put in SHA-3 if you want for those 3 sizes. And again, we're offering 2 KMACs, which is the kind of preferred way of creating a MAC using SHA-3. Next slide. And then finally, for the signature hash functions for use with the digital signature authentication method, we have 4 sizes of SHA-3, 224, 256, 384, 512, and then 2 sizes of Shake as well. Next slide. So to preempt some questions, why not use an AEAD? So AEADs are generally a better choice because you do your encryption and you get your authentication for free. But we believe there are implementations of IPSEC which have kind of separation of encryption and authentication baked in, or separation applied by default. So the default being, HMAC SHA-2 for authentication. those implementations may wish to use HMAC SHA-3 instead of HMAC SHA-2. Even if you are using an AEAD for your authentication, you've still got your PRFs, you've still got your signatures, so you may want to use SHA-3 in those cases. Next slide. Why are we specifying HMAC and KMAC? So I sort of think of this as HMAC SHA-3 is the easy way and KMAC is the proper way. So if you want to do the minimum amount of work to migrate from using SHA-2 to SHA-3, then you can use HMAC SHA-3. It's a drop-in replacement. We're not the only working group working on this, so or we wouldn't be the only working group looking at this. So I believe LAMPS are also standardizing HMAC SHA-3 for use in CMS. If you want to do things properly and get the performance improvement, then you may want to use KMAC. And yes, as it says, using KMAC and PRF Plus will be more efficient than using HMAC SHA-3. Next slide. Cool. That's my pitch. Do people think this is a good idea? If yes, do we want both HMAC SHA-3 and KMAC? We have implemented this. We have test vectors. They're included in the draft. We'd be interested if anyone else wants to implement this and verify our test vectors. And yeah, does the working group want to work on this? Oh, there's a queue. Daniel.
How important do you see the HMAC 224 use case? Most people are trying to sort of sunset 112-bit encryption at the moment.
Yeah, so we haven't included a code point for HMAC SHA-3 It's only for the signature algorithms. And that's because the signature algorithms were basically copied from something that LAMPS were doing. LAMPS were looking to standardize SHA-3 for use in CMS, I believe. Whereas the HMAC SHA-3 algorithms, the sizes were copied from RFC 4868, which only has 256, 384, 512. I don't have a strong opinion on it. So if people don't like SHA-3 I don't mind getting rid of it. There's a note in the draft which says, should we include this? So Scott.
Okay, Scott Fleur, Cisco Systems. I would have to say that HMAC SHA-3 doesn't make much sense from a cryptographical standpoint. For one thing is the proof behind HMAC assumes that the hash function is Merkle-Dangard and SHA-3 is not. In addition, HMAC was basically designed to get around the link extension attacks on SHA and on Merkle-Dangard, and those do not apply. To me, saying KMAC only makes more sense. Thank you.
Absolutely, yeah. I agree that if you want to do it properly, KMAC is the way to do it. We're currently offering HMAC SHA-3 as an option just to make migration easier, but if people don't want that, then we don't have to include it.
Yeah, thank you, John Mattsson, Ericsson. I'm very happy to see more work on using Keccak in different protocols. In addition to the reasons you mentioned, there's also much easier to make side channel resistant. Ericsson is planning to move as much as possible to SHA-3 during the PQC transition. Will probably not happen 100%, but I agree with, I would like to see, I think personally it would be better to only have KMAC and shake and skip HMAC SHA-3 and maybe the fixed versions of SHA-3 in general, but I'm also not opposed to it, but I don't really see any reason of having them.
Okay, thank you.
Valery Smyslov, LS Plus. So I have one comment from implementer point of view. So I think that, as Scott says, from cryptography point of view, using KMAC as PRF is the best option, but from protocol point of view, IQ2 is not yet prepared to negotiate a PRF plus that is hard-coded in the IQ2 RFC. So we can't negotiate, we can't change it easily. We can easily change a PRF function that is building part of the PRF plus, but not the PRF plus construction itself. And if we stick with KMAC as a PRF plus, then I think some changes in the protocol, in particular in the negotiation process of the transforms, that is complicated already and is it doesn't change from the very beginning of the IQ2 need be done. So this is my concern.
Yeah, I think that's reasonable. I think something we can discuss on the list.
Paul Wouters, speaking as individual. So with my implementation hat on, I still have smoking burn marks of trying to make IKV1 and IKV2 as compatible as possible, or supported in the same connection configuration so we can easily upgrade and migrate. And then in the end, what happened was all the vendors just froze IKV1, started a whole new implementation stack for IKV2. These things never met. And here we are with an implementation that can be really flexible, and it was never ever used, and it gave us a lot of headaches. So in that sense, while I applaud your migration support that you're offering, I think you should just forget about it and say, let's drop all these things and just do the new thing, because people are just going to freeze their code anyway. So that's my implementation hat on. Then with my crypto options containment field hat on, I would at least hope that we are doing experimentation and work on this, which I think is really interesting, using code points where possible, where our registries are big enough, and I think they are for IPSEC, without immediately issuing an RFC. So I'm hoping that you're happy to stay in a draft for a while we figure out, what are we going to do internet IETF wide on various algorithms before we commit to various decisions that might make sense for IPSEC, but maybe when we do it at the IETF whole, we move another way, or we take more new information from CFRG about how to do things. So I'm trying to avoid like the 90s problem again, right?
Sure. Yeah. Okay. Cool.
Sorry, and more about this crypto discussion will be again at the SAC on Thursday or Friday. So come show up there.
I will be there.
I'm Quinn Dang at NIST. I have one of my comments. Recently, we had a call for comments and submit suggestions on whether we were going to specify authenticated encryption mode based on CatCheck. And so there is a chance that that is going to happen. I just don't know, which way. But we put out a call, and it ended last month, like I think on the 17th of October.
Okay.
So I think if we did a CatCheck based crypto system, I think that would be a big transformation in IPSEC. I think a lot of big servers or hardware vendors, they have their chips in the big machines to do all the VPN and all the tunnels. If you did it in hardware with CatCheck, that would be amazing, because in the future potentially you could do everything based on one permutation, and it's very efficient, very side channel protection efficient, and also energy efficient. CatCheck is very environmental friendly. Reuses much smaller and hardware energy than compared with SHA-2 and the other candidates during the SHA-3 competition. And it's yeah, so it's good in security, and it's very good on the energy use as well. And so I think that would be a great opportunity for this standard body to think about it, and that would be a big improvement for the ecosystem.
So we're running out of time, so try to be very brief. And I already locked the queue a couple of people before. So, but I will allow like 5 seconds for those 2 people who are now in the locked queue already. But 5 seconds only.
Okay, so here's Guilin. My comment is that this drafts look like a very basic one. Maybe it can be considered, I mean, not just for IPSEC maybe. So whether it should be considered in like a CFRG, because it is replace like the HMAC or KMAC. Yeah, maybe other protocol also consider this thing.
I have not thought about that.
Yeah, I don't know. I just raised this question. Okay.
Okay, very, very short comments.
So feedback, Bjorn Hase.
Hi.
If you can find a way to avoid this hassle with HMAC and KMAC in your protocol, I think that would be a good idea. I've seen a lot of recent CFRG RFCs or drafts, which became really complex for dealing with HMAC and KMAC. So, and I think it would be fine if you find one single solution and one approach for making, avoiding the need of HMAC for SHA-2 might be to try to use a prefix-free encoding, so to prepend the length of the fields to the items that you want to hash. So this might be a way to be as efficient and avoid the HMAC need in SHA-2 in the first place, so that you could use the same approach as you may use safely for SHA-3, also for SHA-2.
Yeah. Wait, let's take it to the list.
Yeah.
Bob Moskowitz, HMAC was this beautiful thing. Let's get off it. KMAC is here. And not only that, ASCON uses a KMAC structure. So moving to KMAC now also positions us ready to start moving, also supporting ASCON. And that's all I want to say. Thank you.
All right, cool. KMAC only it is.
Okay, so next one.
Thank you. Okay, so I would like to present our draft. Yeah, actually, due to the visa reason, I cannot attend the Vancouver meeting. Yeah, Vancouver meeting on site. So I would like to give still a very brief overview about the draft and talking some about our update. Yeah, so this draft actually is quite simple. So we just would like to use a FreeDO KEM, yeah, for IKEV2. So here is the draft information. The basic motivation is that we would like to say maybe a number of a sizable of different algorithm to support the different protocols, especially like for IKEV2. So for this update, we actually change the title of structured content to focus on just the user FreeDO KEM. The previous version, but also mixture with the can combine with the MLKM as well. So make it not so focused good. Yeah, so we get the comments. We change this part. Another part is that we try to do some experiment to show what is the efficiency difference compared with just the user MLKM. Okay, next slide. Thank you. Yep. So here's some difference. So the most thing is about is this one. So FreeDO KEM is actually in the process of ISO standardization. Yeah, likely it can be finally standardized around the end of next year. So compared with the MLKEM, the formal specification by NIST just released, something like 2 months ago. Yeah. So here is a draft. Talking about how to use MLKEM in the framework of the RFC 9370. So we are doing a similar thing, but just use FreeDO. Okay, next slide, please. Yeah, here is a comparison about the ciphertext size and the public key size. Yeah, I think this is a very big difference between MLKEM and the FreeDO. So basically we can say, for the similar security level, ML and FreeDO, MLKEM and FreeDO, FreeDO exists something like have the 10 times of the key size. But the good thing is that the security based hard problem is different. So FreeDO is based on unstructured lattice problem. So in some sense, we can say it's more conservative. But the efficiency cannot compare with the MLKEM. This is the most biggest difference between two KEM scheme. Okay, next one, please. Okay, so this is an example show how we can use FreeDO in the framework of RFC 9370, which defines what is the framework we can do by use the intermediate change. So that the additional of PQ KM could be run under the structure of IKEV2. Okay, next. Okay, this is about our experiment. So we tried to analyze or tried to show some performance result. Yeah, by setting 3 parameter sets. The first one is the control group. Yeah, which just use the X 2559. Yeah, ECDH. Yeah, plus the deletion, because we also consider the authentication part as well. So this is the main part for us. But we would like to see the performance difference if we do both the key exchange together with the PQ authentication together. So we use the deletion 5. For the KEM, we just use the level 3, security level 3. So we take the medium security level for both MLKEM and also for the FREDO. So we have 3 parameter sets. First, the control one. Second is just use the Kyber combined with the deletion. Yeah, third one is we use the FREDO, plus deletion for authentication, digital signatures. So the left side shows what is the packages we need to consider, because we need to transfer the large PQ public key together with the large ciphertext for the KEM to encrypt and decrypt the secret key. So in that case, for the control group, yeah, we need a 16 package. And for the Kyber, yeah, MLKM, so we need 8 package. Package means the IP package. So each package is about 1,500 bytes. Yeah, so for the FREDO one, combined with the X25519, yeah, plus deletion 5 for authentication. In that case, it need about the 40 package. Yeah, this the expert environment is given below. Basically, we just use the open source strong swing, yeah, with the PQC algorithm, yeah, to run, and it our simulated environment, not in your real network scenario. So we just try to test to measure the handshake, yeah, time delay. But we consider for 3 kind of security, 3 kind of the packet loss. Yeah, packet loss will have a big impact about the performance. So here we consider 4 kind of the packet loss. The first one, no packet loss. Another one, 1%. Another, 2%. The last one, 5%. Yeah. Okay. Next, please. Okay. So here is our basic result. So from here, actually, we can show, yeah, if there is no packet loss, in that case, actually, either the control group or with the MLKM or freedom, actually the handshake delay is not big difference. Yeah, but of course for the freedom, because it have more package needed to be sent out, needed to be transferred to each other. So in that case, we need 55, something like 55 milliseconds. But once the packet loss is become higher, so you can say actually the delay could be very long, sometimes more than 4,000 or even 12,000 milliseconds. It means 4 seconds or 12 seconds or something in the worst case. I think this is not just because we have more packets need to send out. The most important reason we think is that about the mechanism of the retransmission in IPSEC or in IKEv2. Because for IKEv2, once one packet is lost, the whole message will be sent out again. Yeah, in our case, such a whole message could be more than 10 packages. Yeah, and another thing is that to resend the packages, we need to wait 4 seconds. So this 4 seconds is a lot of, well, once some packet lost, will introduce a lot of the time, time delay. Yeah, this is the main reason I think. Okay, maybe next one. Thank you. Okay, this is our last slides. So we would like to do more experiments. Yeah, give more better result explanation in future. Yeah, we will. I don't know. Maybe do we need to align with the ISO for acquiring its BQCKM standardization progress? either for FreeDO or even for some other algorithms, especially for Michaelis or for future other algorithms. Also, any other comments? Yeah, thank you.
Okay, so we have about 30 seconds for questions or comments. So be very brief.
Paul Bartos, individual. Just wanted to say that you shouldn't need to resend 12 packets if you have packet loss, because you should be able to actually, with the fragmentation code and the IC intermediate, you should be able to just send the ones that you're missing, I think. But maybe Valerie can correct me on that.
I will. I think you are wrong here, because IC fragmentation is designed in such a way that if any fragment is lost, the whole message is resent. So this is a limitation, and I think that it's better to use TCP, RFC 9329, in this situation when you have to transmit a large messages in IQ2 with a high probability of packet loss. But this have a penalty that ESP will also be used with TCP that badly influence its performance. But there is a draft that separates transport for IQ2 and for TCP. I will send the reference to the chat.
Right, thank you.
Okay, yeah, maybe I catch up with you later. Yeah, thanks.
And last comment.
Yeah. I don't think IETF should refer to any paywalled ISO standards. And then NIST is considering standardizing bike and HQC. My view would be that MLChem plus bike or HQC would be a more conservative choice and also have better performance than FrodoChem.
Yeah, I think so. Yeah.
All right.
Security. Yeah. Thanks.
Let's go to the next presentation and bring that question for the previous presentation. Andrew, you can bring it to the list, and if you have any comments on that. So we are running out of time, so we'll have to be fast.
That's my idea. Hi, I'm Anthony. This is a simple draft. I'm doing a very quick status update and looking for what should be the next steps. So next slide. So initially the goal was much bigger, like rewrite this document, extend the beat mode and everything. And now we've simplified the goal to very minimum thing, get a code point for interoperation and negotiation using IQ2. And the format of the wire format has already been specified in 2015, and it's been in use widely, like I would say widely, some people may argue about it. Next slide. So again, just a one slide recap. This is all about host-to-host IPsec, saving 20 bytes in IPv4 and 40 bytes in IPv6 without any extensions and options, and that brings some savings on the wire. And as Chris pointed out, that is a considerable saving if you go, even though the numbers looks very small, 20 and 40 bytes per packet. And it's already been used by HIP for a long time. And the minimal IPsec is specified it. I don't know how much of it's implemented, but we use it for the IPsec host-to-host connections. Next slide. And the software support has been there for ages, and it's over 20 years. So next slide. Since the IETF 120, we really focus on the code point, and the document is minimal to just get the code point. And the packet format, getting a new document has been RFC 7402 authors has shown interest. And I try to help Bob with that. And so they will write a separate document. I would prefer to separate the path of these two documents separately. They can go together, at least in the early stages. And at later stages, we may have to wait one for the other. But I would prefer to push this first than as now and wait for it later, if necessary. That's it. Next slide. So I think I'm requesting working group adoption here if there's any other feedback.
Let's see where we go. No comment. All right, you can go to the next presentation.
Just as a chair format, like what should we do to get a call for this working group?
So send an email to the list and saying that this draft is here and you would actually like to get it working group adoption for that, so people can comment on the list.
So I'll go to the mic and Chris Haps say I support the adoption.
So you're going to ask for working group adoption, and Tira is going to send out a message saying, "Are we going to do working group adoption?" And 2 weeks later, you're going to say,
No,
yes.
actually, I want to have some discussion on the list first happening. So if he sent the email to list saying that this draft is here, get people comments on that, and two people think that do you think it's ready for working group adoption? Yeah.
So you're going to wait a couple weeks for comments.
Yeah,
You're
yeah,
gonna-
and then-
you're going
then
to
I-
pitch people and make them make comments.
Yeah.
And then you're going to say working group adoption, yes.
Yeah.
Yes.
And 2 weeks later, working group adoption will be done.
Or not.
So we can like, well,
and I also need to
let's
talk to
think
our,
positive,
my
positive.
AD to ask if this is actually in charter.
Yeah, okay.
And then I need to check it out myself to see actually whether it's. I think it's in.
But it's little, right?
I think it's a little, yes.
Yeah, so,
So I think it should be, but I want to check it myself.
so maybe by the time we do this again in Bangkok, we'll have like a working group document.
Most likely.
That'd be awesome.
Right.
Thank you. Okay, so the next one is a bit more complicated, but I still think this is also a very small item. This involves more implementation, which is not implemented. I'm mostly going to recap it. Like I'm not going to give the complete sales pitch and advantage and everything. It is as a reminder, like it's about diagnosis of the IPsec issues we see in the wild, and some people might say it is all corner cases. It should not happen in a real network, but our argument is like when it happens, we are completely helpless, and those situations need to be addressed, and we need a diagnostic protocol for those very corner cases where the operators are really frustrated and cannot go do anything else. And so I listed out some of the use cases, problem statement. Most of the problems are really, you can say like stupid misconfigurations on the network or things which are dynamically changing should not change. It happens. We all encounter it. So let's have a protocol for it, to some way of detecting it. The ping has been there for like last 50 years or something. And I think that's the best thing ever discovered by the internet, arguably. So next slide. So this again, like the use cases to say like it's basically to determine whether you're doing something with a ESP packet which you should not do normally, or which you said you would not do, but it happens. The only fancy thing we really added is when there are multiple ESP paths, one probe can query to be returned via different paths you have, and that's for the use cases when you have multiple essays between same destination for the same traffic related. That one we don't know how to implement it completely yet, but that once its document is adopted and we go to some people implement it, then we will come back and say like this is how exactly to implement it. So next slide. So to recap from the last IETF, so I uploaded a new document, which is I thought I updated it, but it only happened like yesterday. So we added a IQ to notifier. It's just as in case to, so that the one peer can you really expect that somebody will respond to it, but it's not a guarantee that you will get a response for every ping packet you send. That is not required. Like it is, you can still decide, the local policy can still decide like I'm overloaded, I'm not going to respond to ESP pings, or rate limited, just typically as you do for ICMP pings. From the hallway chats, and I've come across there is a lot of interest to it, and some people say we'll implement it, but I haven't seen much on the mailing list yet. Next slide. So this one needs some work, but I think there will be only work once there is working group adoption. Like the people who shared the interest said like, wow, if there is no working group adoption, we won't implement it and we won't get more feedback. So it is somewhat in a kind of like a dilemma, like should we ask for working group adoption and then work on it? And then if it's not good, throw it out, or how do we proceed? Any advice from the chair or?
Hujin from Nokia. So I have a question. Sorry, I haven't read the draft, but I think this work is useful because I also saw the problem that ESP doesn't go through, but IKE is fine. I saw that problem myself. So I think that's a right use case. So one basic question I have is that, so on IKE we have DPT to detect the keep alive, right? So for this, if there's conflict between IKE and this ESP ping, so what do we do?
So the IKE's packet is a different fate than ESP.
Yeah.
Right. There are some minor differences. Exactly. Like when you send a DPD as a detection tool, and it cannot do large, and current DPD can only do very limited things. The connection is alive. It cannot do like MTU detection and other things this can do. This will help you to actually send a larger packets.
Yeah, but my question really is that, let's say for DPDs, from DP point of view, it's still good, everything's still good, but ESP says
Exactly.
it's that. So
Yeah,
what's the behavior?
That's the case we are trying to detect using the ESP ping, and in those cases, like the DPD and IKE says the connection is good, you can send packets. But when you actually send the ESP pings, it will probably won't make it.
So in that case, we rekey or tear down the SA?
No, at least you get to maybe like administrator will say like you misconfigured your MTU, so at least you will get a proper number saying like this is a number I should be doing, and you can at least reconfigure it. Now I don't think rekey will not help you in most cases, as I know. Or in some cases, you should just tell the operators like you should not do this.
So just like an event generate log, something like that.
Yeah. Or it may be like you may have to go and renegotiate with your network
Yeah,
operator.
I'm just saying maybe there's also cases when you want to tear down the tunnel and recreate the tunnel, something like that.
Or at least you get some more information. Otherwise, you're sitting in the dark and you have no idea. Like you're blaming each other. Like what really happened?
All right.
Okay. Thank you.
That's the time.
And I just remind people to use actually the meter code.
Yeah.
Or get to the queue. Yeah.
Stefan Klasser, speaking as one of the IPSEC maintainers for Linux. So we definitely will wait for the adoption call before we start to implement anything. So I really would recommend to do the adoption call that we can start to work on that.
All right.
Another question is, we also had this non-encrypted ESP ping. What happened to that, by the way? There was a discussion at the last meeting. Maybe we should combine these two drafts or draft them separately, but I haven't heard anything about it.
I haven't seen anything in the list. Which means that usually you are supposed to do things in the list also.
Michael is on the chat. Is Michael has to say anything about it, or no? Michael is on the online.
All right.
Okay, that's all. Thank you.
Well, the next one, big issue out. We have exactly the amount of time we actually have a presentation.
Oh, okay.
So 10 minutes for each of the
Okay.
presentations.
Okay. Okay. Let's talk about post-quantum authentication. Next slide. Post-quantum crypto. Post-quantum computers breaks a lot of problems. RSA, Diffie-Hellman, ECDSA. So we're in trouble with what we currently use. Next. Again, IP2 uses, of course, if you use certificates, we basically are RSA or ECDSA, and those are all vulnerable. If you happen to use pre-shared keys, you're good as long as those are reasonably sized. But we all know that there are issues with that. So what we're doing is introducing post-quantum signatures for authentication, basically to enhance security against future post-quantum quantum computers. Now, quantum computers are probably not going to be around for 10 years, and so why do we do this now? Well, basically because part of it is the whole, we have to migrate the whole certificate architect and infrastructure, and that's going to take time, so we have to get started relatively quickly. Next slide. NIST are in the process of standardizing a bunch of algorithms. Right now, they have published 3: MLChem, MLDSA, and SLHDSA, with Falcon coming relatively quickly. And we are going to focus on the 2 of them, MLDSA and SLHDSA. Next slide. And for MLDSA, we already have a certificate format proposed over in LAMPS. Basically, it comes into 3 security levels: 40, good, better, best. DSA 44, which is designed to be as hard to break as finding a collision in, say, SHA-256. DSA 65, which is designed to be as strong as AES 192, and a DSA 87 as strong as AES 256. And we support, we'll be supporting all three. Next slide. And as far as SLH DSA, again, it comes in 3 security levels, and it also includes both variants for both small and fast, or I like them to call them slow and fat. And and they also can either use either SHA-256 or SHA-2 or SHAKE-256 as a hash function, and so we end up with a total of 12 different variants, and we have support for all 12. Next slide. Now, they both come in both deterministic and randomized versions. Basically, deterministic means that you sign the same thing twice, always the same. Randomized version comes out different. Obviously, we can do sort of both, but because I always sign distinct messages every single time, we can work with the deterministic version. And they both allow for a context input and also allowing for pre-hash. We're going to do the simplest approach, which is actually having an empty context string, and we're just going to do pure mode. Pre-hash is interesting only if you're hashing a very large message, and IPv2 never does. Next slide. And signaling support, which is not, there's a couple different ways we can do that. We're still undecided. We could indicate it in the certificate request payload, or we can also leverage the IP2 auth announce to say which ones we support. And I think that's about it.
Yeah.
Yeah. Suggestions and comments are welcome, and we're asking for working group adoption. And also, in addition, the next talk we'll be talking about having both post-quantum and classical authentication at the same time. I believe both drafts should be are worth consideration.
Can you use the media code? Oh, you haven't. Okay. It would be easier because the people were remotely. Okay.
Who from Nokia? So you mentioned that this you want an announcement also was a certificate request payload to negotiate this post-quantum MRDSA or SHA-DSA. So I'm wondering for the OS payload, are you also using the digital signature OS payload?
For the auth payload, I believe that will just be doing it exactly the same IP2 does. That auth payload would be a signature, just like instead of using a classical signature, would be using a post-quantum signature. Am I completely misunderstanding your question?
Well, there are a few in the IP2 history. There are a few different way to do digital signature. So the latest way is it's actually called digital signature. RFC 7427, I believe. If that's what you mean, I think you should put that in your draft to make it clear.
Okay.
Yeah.
Yep. Any other comments? Questions? And I think, yeah, actually, everybody who wants to have their draft to be adopted to working group, send an email to the mailing list and ask them that, okay, I think this is ready and this should be adopted. Because otherwise, if you say here, oh, yeah, I probably forget everything. All right, so.
Okay.
If there's no other comments, then
okay.
We actually gained a couple of minutes. Oh, there. 80.
That's just your ID. I'm just turning the thumb screws a little more. So when they ask for adoption, you're gonna. Yeah.
We are going to be some discussion in the list, and then.
Like not, like, within maybe before Christmas.
If they don't do it before Christmas, they don't get their draft adopted before the next IETF. Let's make it this way.
I think the authors are normally
lazy. Yes.
No, that's not the word I was going to use.
Oh, you're busy.
The authors are normally motivated, but then we need the list to be motivated and chairs to be motivated, and like I'm just pushing the motivation.
Right. So you want people to be active in the list, to be actually, other people also than the authors only. All right. So next one is Joanna.
Okay, thank you. This draft is same topic as the previous one. It's about post-quantum to use in IPv2. So this one is about the hybrid authentication when you use both post-quantum, like DSA, and with traditional one like RSA or ECDSA. I think the problem is that the new algorithm is good, but it still need time to be field proven because there could be flaws in the specification itself, or there could be flaws in the each implementation. So some people have the concern that if I use only the new algorithm, might not be that mature at the time point. So this draft proposed to use at least one traditional algorithm plus one PQC algorithm like MRDSA for the IPv2 PKI authentication. So that as long as one algorithm is safe, your whole authentication could be safe. Next, please. So if you follow the discussion around other IETF groups like LAMPS, you will see there are actually two PKI setup in the discussion right now. I call it type 1 and type 2. So type 1 is basically you have a so-called single certificate with composite keys, which means you have one certificate contain both traditional key and one PQC key. The type 2 is you have two certificates which represent the same entity, but one certificate is your traditional RSA certificate, for example. Another would be the using the new PQC keys. So to simplify this draft, I propose to use a single way to address both these setups. So we will always use the hybrid authentication in this draft as using the way of how the composite key is computed for both setups. Next, please. There's some design choice when I write this draft. So for reason of efficiency, that there was a draft, there was RFC 4739 that allows IPv2 to do multiple key authentication exchange. However, given this new quantum hybrid authentication, the whole IPv2 negotiation is likely to be used along with the hybrid key exchange. As you saw in the previous presentation, that could be a very long exchange, including many packet exchange. So I don't want to adding more exchange unless we have to. So that's why in this draft, I propose to always using a single authentication exchange for this hybrid authentication. However, if there's a reason to do, if you think that's reason to do, like say, for example, you want another round of IPSECME authentication, you could still use this draft along with RFC 4739 to do that. This draft does not prevent you to use that multiple authentication exchange. But if you don't have that actual requirement, you can simply use the one authentication exchange to do the hybrid authentication. The hybrid authentication as payload format is same as the RFC 7427, which is a digital signature authentication payload format with the new INA assigned auth method, because what we propose here is a hybrid authentication. That's why we ask the INA to assign new auth method value. So as I mentioned that here, even though we have involved two different type of keys, but we will always use a composite signature computation for both type 1, type 2 setups. And also to avoid reinvented view, we will follow the LAMPS draft that using the composite signature scheme, specify this in this LAMPS draft to do the computation for both setup. And also we were using the announcement, also method announcement of the 9593 for the announcement of this hybrid authentication support. Next, please. So this is the example of call flow with PPK. So PPK is additional post-quantum pre-share key. This like before you do the full hybrid key exchange, you can use this hybrid authentication with the PPK. This gives you the post-quantum resiliency for both key exchange and also for the authentication. So as you can see here, it's pretty simple. First, the responder will signal the support of the hybrid auth authentication in the announcement, along with the use of PPK and identification. And then initiator will choose one of the algorithms that the respondent advertise, and then send its auth payload that compute with both keys in the hyper authentication manner. And then responder will do the same in this auth payload, and also pick one that initiator and advance announced that what kind of combination that initiator want to use. So that's a call flow. Next, please. So here's the announcement. So announcement is defined in RFC 9593. In this draft, we define a new format here. So in this format, the auth method will be the new value, the INI assigned value, and then there's a set link, a logarithm flag, and also the logarithm identifier. So we can have up to n of those logarithms. Each one of them identify a combination of multiple algorithms. One is your traditional algorithm, one is your post-quantum algorithm, and then there's also hash algorithms that depends on your either use along with the traditional algorithm, or you, in case of like, for example, in the MLDSA, if you want to do pre-hash, you still also need another hash algorithm for that pre-hash functions. And the third link here have same meaning as the defined in the RFC 9593, which is basically to say which CA that these algorithms go with. The flag here is basically have two bits here. One corresponding to type 1, second corresponding to type 2 PK setup. So basically means that if this one of these bits set, so this algorithm is okay to use with this type of PK setup. So this basically give you the capability to announce what kind of combinations and what kind of setup go with it for each of these combinations. So next. And then to generate the auth payload, depends on if you are type 1 or type 2. Again, type 1 is you're using the single composite key certificate. So here, the exact algorithm, we follow the LAMP draft with a few inputs here. So first you have the SK, the private key for the composite key. M is your input message to sign, which is, we don't change that. It's still the what's defined in RFC, IPv2 RFC. And also the context here, I define a new context like IPv2-PQD-hybrid-auth. The reason I define new context here is because since we are using the LAMP draft for the signature generation, so that but we use that in our IPv2 applications. That's why I put it in using different contexts here to make sure to differentiate our IPv2 use of this signature generation method versus the LAMP's use of in their applications. So in type 2, where you have two certificates, like one RSA, one MLDSA, in that case, it's almost the same as the type 1. It's just instead of a composite key, you have two separate keys. So you use those two separate keys directly in the same algorithm that defined in the LAMP draft. Okay, next. Okay, I think that's about it. Questions?
Palvartus individual. I noticed that you're using PPK and a post-quantum algorithm there, which to me sounds a little weird because the PPK, which is the post-quantum pre-shared key, is the whole point was that we didn't have PQ yet, so we'll throw in another PSK to help. So
Yeah.
if you're using PQ, I don't understand why you would still also use PPK.
Yeah, PPK is for the key exchange part of the IPv2. So IPv2 has two parts, right? First you do key exchange, and then you do authentication. So my draft is for the second part, authentication part. So when you have today, there's many IPSECME deployment using the PKI authentication, and they are using, for example, RSA, ECDSA keys today. But now they are want to move into the PQC type of algorithms. So this gives you the hybrid authentication capability to do that migration. So PPK is really for key exchange only.
Hi, Russ Housley. I'm quite concerned about your use of the context string. We are having a massive argument about it in LAMPS, and wait, because the big issue is many of the APIs like PKCS11 don't have a way to pass it down to the library yet.
Yeah, I think my comments here is really because since now I'm trying to reuse the LAMPS work. I know that's discussion still ongoing, so this also will be follow up that work here there.
Okay. Scott Fluor, Cisco Systems. It strikes me that by trying to handle both use cases, type 1 and type 2, this is overly complex. And especially, I think you're overlooking some of the complexity of multiple certificate chains, in particular, how to negotiate which ones you want. Do you want, if you ask for 3 certificates, if you allow for 3 certificate authorities, do you say which ones do you need?
Yeah,
etc. Yeah,
that's covered in the announcement part. But time limitation.
But that is complexity. What I would suggest you do is we sit down, have an argument about which one we want, type 1 or type 2, and support only that. That would simplify things significantly.
Yeah, but my worry that it's not really up to IPSec people to decision, right? This is a PKI setup. It involve a lot of other components.
Yeah, yes, at the PKI, the LAMPS people are also waiting for use cases because they don't actually, they are just developing tools that people like us use.
Wow.
I think it's a negotiation. We don't just have to take what they give us. They also have to. We tell them what we need or what we want.
All right.
Sure.
One more comment there, Daniel. On Big East.
Yeah, Daniel Van Geest, in addition to what Scott just said, for the type 2 situation, the composite signatures draft explicitly forbids you from using 2 component keys separately and then combining them into one signature because of various non-separability issues. So you might want to take a look at what's happening in LAMPS to learn more about that.
I think we are going to be following LAMPS stuff for that. All right, so I think that's for that. Then let's move to my final presentation. We have 9 minutes.
Okay, next page, please. So we present this last IETF at the old dispatch and got quite a few comments, and was told actually this IPSECME is the place with most expertise who can give the feedback. So general background is we have a cloud backbone which hosts services for enterprise, and besides the like A and B are the enterprise CPEs, and they do have traffic to be hosted in the cloud provider, which you have IPsec sessions. So the traffic terminated within the cloud is basically decrypted and then connect to the services within the cloud. However, they do provide the transit services. From A to B, they have end-to-end IPsec encryption for the payload, and they will add the overhead encapsulation header to the entrance ingress gateway, indicating where they want to exit. So this draft is really to add an authentication methods for the encapsulation header. Next page, please. So this just illustrates what the bytes and bits to be encrypted. The payload itself is already encrypted end to end. And here on the top is the like Geneve header, which indicate where's the egress point, and maybe also include some other information on the steering, like you may have some transit nodes you indicate in the header. So we will add this authentication for the header to prevent anybody in the middle between A and the gateway, the middle network, anybody tampering with the header part. So that's where it is. Okay, next page. So the feedback we got from the last IETF is really we need to add a section on the key management. So so this is in this new version. Basically, this is really lightweight authentication. The generation of the key is managed by the backbone. The backbone network on cloud operator control the key, and it's a symmetric key to be distributed to the edge. And each SD-WAN session has their own keys. And the edge device is responsible for securely store the key. And then there will be like a set of keys, so that is the edge device initiate the key rotation. Like they may use the key for days or hours, depending on the configuration, and then they rotate. And they will have a key index to indicate which key they use. And every time if there's the session being terminated or the timer expired for the key, there'll be key being regenerated, a new set of keys to be distributed to the edge. Next page, please. So for the distribution, there are several ways to distribute the key. One is there's a secure channel, like supposedly there is a TLS channel between the controller and the edge device. So the symmetric key will be distributed through the secure channel. It could be also from the data plane, because from A, here is E, the edge device, to the gateway, there's an IPsec channel already for subset of the payload, and they can use that channel to distribute the key. Another way could be through the regenerated from the IPsec, because from the edge to the cloud gateway, there is an IPsec channel, and there will be IPsec keys, and that key can be reused to generate the key for authentication code. And that's it. Next page. So here we're just saying that the reason we call lightweight is saying that not every flow need to authenticate a header. Maybe only a subset of flows, like from the edge device, they may have lots of traffic going for internet browser or whatever. Maybe that's not important. They don't have to authenticate the header. But for some important flows, they need to authenticate the flow. So which flow to need authentication is really through the control plane. From management channel, tell the edge node which node need to be which flow need to be authenticated. But nevertheless, all packets will have this authentication code in there, just to say that anybody in the middle cannot detect which flow actually is being authenticated or not. Next page. So we present here because there are lots of expertise in this room and in this community. We would like to get more feedback to see if this method, if any problems and flaws.
Chris Hops. So did I hear right that this is a authentication between gateways, but you expect there to be underlying encryption end to end?
So from A to B, they have end-to-end encryption for the payload. Like say, for example, A needs to send traffic to B, right? That there's an IPsec channel between A and B.
So those aren't
however,
routers.
we will need a check.
No, so I was asking, are there hosts behind A and B that are encrypting?
Oh,
no.
That's not in the scope. We don't care. Like
So if it's encrypted, what is the authentication above and beyond that for?
Is for the actual header you added, because like for example, from A to B, I want to steer the traffic from gateway 2 to P2 to P3, and then to gateway 10 to egress, right? So I add a big chunk of header to indicate the steering path. So I don't want anybody in the middle between A and gate 1 to mess around it. So if there's somebody malicious user in the middle, they may change the header so that my traffic supposed to egress from gateway 10 end up going nowhere. Like for example, they may change the header so that my traffic may go to like gateway 100 over there. They just cannot reach that anymore.
So you are saying that we have an A and B has an IPsec tunnel, but A also would add an source routing header to the outer packet, or non-encrypted packet, that will be parsed by the gateway 2 and P10 and so on. And you want to make sure that those devices, the gateways that are routing it, can verify that header. So it's independent from the IPsec layer.
Yeah, it's like a segment routing. You're authenticating a segment routing stack or an MPLS stack. But is this an actual problem? I mean, have we seen this in the world?
Well, there was pointed to us when we had this multi-segment SD-WAN in the RTG working group. It was pointed out there's a security risk of you added so much header on how to steer the traffic, and there will be some malicious user in between A and gateway 1 mess around with your header, then your traffic cannot get to your
So
intended
you would
destination.
have to authenticate at every hop for this to be useful against that attack.
No, not every hop, because we assume in the backbone they have their own secure mechanism. It's the internal network belong to a particular provider. So the only authentication is the ingress node to make sure that the gateway 2, when they receive the packet, you know that this is authenticated and
Right,
nobody.
but you're not protecting against that. You're protecting against misrouting. So to protect against misrouting, you have to authenticate at every hop
When you every hop in the backbone hop, so
along A to B path, right?
well,
Otherwise, who cares? The person messes, they've accomplished their goal, whether you accept the packet at the end or not. They've misrouted your packets all over the place. That's what they were trying to do in the first place.
Okay, so we're assuming it's like this, like from A to B. For example, A is in Dublin, B is in San Francisco, and A, the first hop is the first gateway, maybe only like one hop away from A, and then we just make sure that when the gateway ingress node receive the packet, the header is intact, hasn't been tampered, and then it's up to the backbone. They may have their own MPLS network, they may have their own private link to send the packet based on A's intent to the egress. And then once it get to egress, going to San Francisco and send it to B, then that's like, we're assuming this like a last mile so that gateway 10 can send to B.
But it got there or it didn't, right?
What is that?
You're authenticating. What are you authenticating? It either got there or it didn't. So the only thing you can protect in this scenario is that it got there the way you wanted it to.
Mhm.
And the only way to make that work is to authenticate on each hop. It's not an IPsec tunnel is what I'm getting at.
Yeah, but anyway, okay. So the idea here was to bring it here, not because this is the IPsec problem, but because there's a people here who actually have knowledge and understanding of this kind of similar situations, is my understanding.
Yes,
so if you
correct.
want to get feedback, what they are doing in whatever they are going to be doing on this, is there anything that you at your feedback is actually good for that? So you should bring that to. And I'm actually wondering which list we should actually be discussing this, because as I said, this is not an IPSECME stuff really.
Yeah. So I mean, Linda, you probably know each other from routing, right? So this
Yeah.
is kind of a hybrid problem. It's a routing and security issue, and I just think that it's I mean, the IPsec tunnel is not going to help you here, but
No,
it is
correct.
like Tara said, it's you're getting feedback from the security here too.
Thank you.
So this, and I've heard this a couple times. It just sounds more and more like the Nasserboff that happened last time. And that.
Oh, okay, yeah.
Yeah.
Maybe there's a similarity to that. I
Because
haven't
they're-
followed that very closely.
So they're talking about like you want your data to go this way, and you're proving that it's hit these nodes along the way and not any other nodes. Like it's not. I'm not going to claim it's possible.
Okay. So,
but
yeah, correct.
Nasser is there's a side meeting today for Nasser, I believe.
Okay.
But this looks more and more like that as you describe it.
I see. I remember I talked to them a few IETFs ago. They seems a very, very sophisticated method to validate the entire path. And here we are only to validate one segment, like make sure that when the ingress, when they receive the packet, whatever instruction they tell me is valid, is not tampered. That's maybe the baby step towards NASA.
I don't know.
Okay.
I don't know.
So
but
I
it-
can talk
But
to
it
them.
looks more like that than
Okay.
IPsec, right?
No, it's not IPSECME, just as Tara said. I
Question
want-
actually, process question actually. So do we actually want to discuss this in IPsec list, or do we actually is there any other list that we could actually use, or should we actually create a new list for this? And because I don't think this is actually IPSEC problem in
Right.
a
I just
sense.
thought this has expertise. This room
This group has an
It's a good,
expertise,
right,
and
that's right,
yeah.
that's right. And I don't know the answer.
All right.
Thank you.
So
Maybe
we
I'll talk to
have
you.
to think about it. Okay, let's start with
That's
let's start discussing this in IPSEC list, and if we
That's
get
the
too
only
much,
other thing that's occurred to me just now is that maybe Nasser might be an option. Maybe this is just a small subcase of Nasser. I don't know.
Yeah, it could be a small subcase of NASA.
all right. So
Thank
I
you.
think that's all we had for today, and we are only 4 minutes out
Thank
out
you.
of time with the last discussion. All right, thank you. So that's everything for IPSECME, and we will meet next time in
Bangkok,
let me see, Bangkok.
I think, isn't it? Where is 122?